So in this video, what I'm aiming to do is effectively get you to understand how a derivative works graphically. In other words, if I give you a picture of an original function, can you figure out, roughly speaking, what the derivative of that function should look like? And so first, just sort of recall this point that I've been sort of pushing this whole past week, the derivative g prime of x of a function. So if you have the derivative, that derivative is a function itself, and the output of the derivative, the output of this g prime of x thing, is the slope of the tangent to the original function. So just remember that the output of the derivative function, the y value of a derivative function, is basically the slope of the tangent to the original function. So with that said, I have this example, right? I've got two functions here, right? One of them is the derivative of the other one, and I want to know which one of them is which and why. So which one of them, basically I'm asking you which one of these is f and which one of them is f prime. In my opinion, the best way to attempt a problem like this is to just guess. Just say, you know what, let's guess that this is f and that this is f prime, right? So now that we've made that assumption, we can start trying to understand this, right? Let's pick a point, right? Let's pick, for instance, this point right over here at -3, right? At -3, if I sort of follow down to the f function and look at that tangent slope, right? If I were to ask you to just estimate, roughly speaking, what does the slope look like there? So you pause the video and you think for a second, and I hope everybody comes up with something like -2, maybe -3 or so. Go over to this function over here. When I go to -3, is the value of the derivative, is the y-coordinate -3? Absolutely not. In fact, the y-coordinate is +3. This couldn't be more wrong. And I hope that sort of makes sense, right? We can confirm this by looking at another point. So let's say that we jump over and we check let's say that this value over here, just a little bit to the left of 1, right? What does the slope of this tangent look like? And I didn't do a very good job of drawing it there, but what does the slope of that tangent look like? Again, it looks like it's a fairly negative value, right? The slope there is probably -2 or so. When I go back over here and look at the value of the function there, the value of the function isn't negative at all. In fact, it's positive, like a half or so. This is very, very wrong. Right? Now keep in mind, you got to be careful when you do this. For instance, if we look at 0, when I follow up to 0, the slope of this tangent line is 0. So sure enough over here, there's a point at 0, 0. So there might be some points where it looks like it's right and it looks like it's working out, but it'll end up not being the right way. So if any single point doesn't work, it doesn't work that way. Okay, so we've concluded it doesn't work that way. Let's try it the other way, right? What if this was the original function and this was the derivative, right? Does this one work? So again, we're going to sort of try it using the same principles we did before. Let's say we pick this random value back here. The slope of the tangent up here is 0. And sure enough, over here at that same point, the value of this function is 0. Right? If I come along and check at 0, the slope right here seems to be about +1. Sure enough, the point on this function is +1. Right? If I go over here and I check at 3, that slope right there seems to be about -1 or so. And sure enough, when I look over here at this derivative function, the value I have here is, it's not -1. Looks like it's -1.4, but it's reasonable. Those things seem to match up. So here's an example for you to try on your own. In this case, I'm giving you the graph of h of x on the left, and I want to know which one of these three things over here is the derivative of this picture, right? So pause the video, think about that for a minute, see if you can match up some slopes and sort of work through it. So just like I did in the previous problem, I'm going to pick a value and sort of think about that tangent slope, right? So when I draw this tangent slope, we would say that's sort of a slightly positive slope. So when I look at each of these options, in this one at -3, I'm slightly negative, which means this one's wrong. For this one, when I look at -3, my point is slightly positive, so this one seems like it, maybe this one could work. At least I'm not crossing it off. For the next one down at -3, sure enough, the point is again negative, which means this one's out. If we want to, we can sort of confirm more points, right? Suppose I looked just to the right of this thing, let's say we look over here at about a half. The slope of the tangent at a half seems to, it's definitely positive, maybe +2 or so. Sure enough, when I look at this graph at a half, the value of the function is +2 or so. It makes sense that that middle one is the graph of the slopes of this original function. And that's really the key here. The derivative is just supposed to be a graph of all the slopes of your original function. So I have one more problem. This one's a little bit backward, right? So this one says the function given in the graph is the derivative of which function. So this one, I'm giving you the derivative, and I want to know which one of these could be the original function. So pause the video, think about that one for a minute. So my thought here is, okay, well, like let's take a value, right? Let's say at let's say at -2, right? The value of the derivative is, like let's say positive a half. So that means at -2, I should have a slope of positive a half. Sure enough, that tangent slope seems to be about positive a half. For this one at -2, the slope actually seems to be like negative a half, which means this one's out. And for this one at -2, this one also seems to be positive a half. So it seems like it could be either the top or the bottom functions. So we could go on and we could sort of test another point, right? What about at 0? At 0, the value of the derivative is -1. So the slopes of these things should be -1. Well, when I look at 0 and sort of draw my tangent line on this one, that's believable as -1. For this one, the slope of this one is also believable as being -1. And so now the question that I would ask you to think about is, look at these two graphs. Do they look similar? They should. In fact, sort of this is a little bit of a trick question. They're both right. Because both of these graphs are the exact same shape, it's just that this one has been shifted up by 2 units. Shifting a graph up by a little bit will not change its slopes at all. And I'm not going to really go into detail about what that means right now, but if you think about the derivative, if you think about this function over here as being f of x, and this function as being f of x plus 3, there's an interesting conclusion for you to think about in terms of what the derivatives of these two things are. And I'm going to leave us hanging there because this video is longer than I wanted it to be. But there you go. That's sort of the derivative graphically.